All right, Sharks, this is Mr. O with Matter 3 flip notes. Matter 3 is properties of matter, 6P23, and in your composition notebook, this is page 15, and that'd be Matter 3 flipped. Now, just to get you started, we talked about physical properties of matter in Matter 2, and we talked about mass, volume, and shape. However, in this unit, we're going to dig deeper into it. So think about Matter 1, Matter 2 had its own unit test. This matter unit by itself has its own matter test. There's a lot of content in here, a lot of little things you have to remember and know and memorize and also be able to apply. So the best way of understanding this unit is talking about it with another person to show you that you really understand it. So let's start talking about some science. Now, physical properties of matter are used for three different things. Just like physical properties of soil, they are used to describe, identify, and classify all types of matter. So if you think back to our layers of our soil unit, soil had physical properties, texture, pore space, fertility, and we use those to classify and determine things about soil. Physical properties of matter is no different. Same three things: describe, identify, classify. And we'll dig a little bit deeper in how well we can do that and why we'll do that. Now, the overarching thing with physical properties of matter is you have to be able to describe something to the point of identification. Meaning, if I'm given an unknown thing, how can I make sure it's that thing over something else? Scientists do this all the time, and they will use physical properties to do so. So in your notes, I need you to draw like a two-box thing, maybe something that looks like this. Basically what we're going to do is we're going to compare two different things. So in the one side of this box, I want you to write the word physical change. And you saw about this in your reading that you did last night or 2 nights ago for homework. And so physical change is when matter changes its form, but not what it is. So basically, if I take a piece of paper and I rip it all up, well, it's still pieces of paper. That's a physical change. If I take a rock and I smash it with a hammer and there's little pieces of it everywhere, well, it's all the same because it's still pieces of rock. It's a physical change done usually through physical action. Think about physical weathering from the weathering unit. That happens too. Examples of this are when things go and change a phase. So if you think of water going to ice or ice melting to water or vaporizing into water vapor, and like I said before, cutting paper, it's still paper, it's still water, it's still H2O. It doesn't change its molecules and its elements. It's the same thing. So this is filling in the one side. Now there's something completely different than this. That's another different type of change, and that would be known as chemical change. So on the other side of that box you drew, you're going to put chemical change. This is when two or more things combine to form something new. They change their molecules and their elements. This is what I like to call a permanent change. This isn't coming back. This is something new. So examples of this, if I take a piece of paper and I burn it, well, when I burn it, it's going to turn into carbon. It's not paper anymore. It's carbon. It changes its elements. Also, baking a cake. You put all these ingredients in and you bake it. You're not going to find baking soda anymore in there. It's a part of this cake that's something new. Other couple of examples of chemical change would be if you mixed, if you're making the volcano, so you're doing that baking soda and vinegar, and you make that volcano explosion. That's a chemical change that happened there. And if I put Mentos in a thick can of soda, it's going to chemically react and be something different. In your last part of your notes, I'm going to have you create a T-chart. So you're going to make a T-chart in your notes. And what we'll do is we'll run down one side, then we'll move down the other side. The last thing we're talking about is independent versus dependent properties. Independent, so that would go up on the one side of the T-chart. One of the things, they stay constant, which means they stay the same no matter what. They're independent, they're alone, they're sole, they're provided. Like you are not independent because you depend on your parents. So examples of this are the three things we learned before in our unit. So we have density, which is mass divided by volume. We have solubility, which is the ability for a solute to completely dissolve into a solvent. And just so you know, the universal solvent is water. We'll talk more about that later. And the next one is melting point, boiling point. There's also other ones like flammability. This is also an independent property. The things about this are the things that never change. These stay the same. These will, no matter what, no matter if you have 60,000 tons of water or if you have 6 tons of water, all of it will melt at 0 degrees. All of it will boil at 100 degrees Celsius. If something is soluble in water, it will always be soluble in water. So oil is not soluble in water. So it does not have solubility. So no matter how much or how little oil you have, no matter where you are, it'll never be able to be soluble because it doesn't solute into water. Density, no matter how much you have or little bit, density is used by jewelers a lot to test if something's real gold or silver because different metals have different densities. The last one would be the opposite of independent properties, which are dependent properties. These can change depending on the object. So no matter if it's all gold, these three things will change. I think I screwed up before. I think I said these are the ones we learned before. These are actually the ones that we learned in our prior notes in Matter 2. So these are dependent. These are mass, volume, shape, and color. These things change. I mean, you can have 50 pounds of gold and all of them weigh differently. You can have 50 pounds of gold and all of them take up different space, all different shapes. Gold can be different color. However, it's all still gold. So that when you see the word, I underline depend because it depends on the object. It does not depend on what it is. So if you think about when you compare independent versus dependent, the more independent properties you know, the better you are at trying to figure out what the object is. Dependent properties just help you describe an object, but they can't really help you determine what it is because it can always change. That's it for these notes. Write down any questions you have for me, and I will see you on Monday.